Good morning. We are visiting fractions again this morning. So last time we worked on fractions, we talked about, the numerator and denominator and mixed numbers, improper fractions, and kind of just went over some basics of things. Did a couple problems, but you mostly used food examples. So in recap, the numerator of the top number of a fraction is the amount of something that fills a container. And the denominator is the information on the size of the container itself, like how big is your container. So when you're doing addition, subtraction, you're only really interested in, once the denominators have to be the same, but you're only really interested in the number that fills the containers. You won't change the size of the container once they're equal. So like, 1 over 10 plus 2 over 10 is 3 over 10. If you've got 1 over 10 and 2 over 5, you have to change the 5 to get the 10. And so again, you don't subtract or take away from the container size, which is the denominators. That's just the information on how big your container is. What you will do is do orders of operation on the numerator, which is how many things are in the container, how many of these sections are filled. So let's work. I got a little worksheet to work through, but let's do some basics. So if I have 1 over 5 plus 2 over 5, which is, again, one section of my 5 sections big object plus 2 sections filled of a 5 section big object is now 3 sections filled of a 5 section big object. And so we used lasagna trays last time. So we said the lasagna tray has 5 slots. A full pan has 5 slices of lasagna. You have 1 slice in one, and then you got another pan with 2 slices. Well, how many could you put in one? So you can fit 3 slices in that one pan. That's a 3/5 of the pan is full. We can do one more, and then we'll work on the worksheet. So you've got 1 over 10 plus 2 over 5 plus 1 over 10. So we need to change the denominator to be the same as 10. So what do we know about the relationship between 5 and 10? Well, we know that 5 is half of 10, or another way of saying it is 5 times 2 is 10. So if I'm going to change this middle fraction so that we can do this operation, I have to then multiply the top and bottom by the same number. So I have to multiply the top by 2, I have to multiply the bottom by 2. So I can rewrite this as 1 over 10 plus 4 over 10 plus 1 over 10. And that would get me 1 plus 4 is 5, 5 plus 1 is 6. So that would get me 6 over 10. Very simple. Make sure you can see that. Excellent. Okay, so that's first things first. Now we will run through a good bit of problems, because that's the one thing about mathematics is you have to do problems. You can't, for history, you can read and study materials, you can look at other people's writings on things. With mathematics, you got to drill. You got to do lots and lots of problems. Okay, so let's do, I have 7 over 10 minus 2 over 5. All right, so we did one like this just a second ago. So again, I need to change this fraction so that I can subtract it from 10. So if I multiply the bottom by 2 and the top by 2, I can make this 4 over 10. And so now my problem reads 7 over 10 minus 4 over 10. So again, we don't subtract away from the denominators. We're only interested in taking away from the numerators. So 7 minus 4 is 3. So you've got 3 over 10. Excellent. Okay, next one. Let's do 4 over 8. 8 minus 1 over 4. Now, one thing to know about 4 over 8, so if I have a pizza and it's cut into 8 slices and 4 of those are filled, how big, how many slices of the pizza are there? So I got a whole pizza and 1, 2, 3, 4 filled. So this side is filled and this side is empty. You would say that pizza is half full or half empty. Half of the pizza is there. So, because you can reduce that to 1/2, and we'll talk more about that later. But okay, so similar problem. I need to get 4 to become 8. Well, how do I do that? I can multiply by 2. Alternatively, you could reduce, but we're not going to do that. We're just going to focus on. You can reduce at the end. We're going to stay consistent with order of operation, and then we can reduce at the end. Okay, so this is now 2 over 8. And so I've got 4 over 8 minus 2 over 8 is another 2 over 8. Because 4 minus 2 is also 2. So now we'll reduce it. So I have 2 over 8. Well, 2 is a multiple of 2, and 2 is also a multiple of 8. So we can take out a 2. So we can divide the top and bottom by 2. And that gets us back to 1/4. So 1/4 is your answer. Okay. Next, we will do. Let's do an additional one. So I did this one. I did this one. All right. So we've got 3 over 9 plus 1 over 3. So again, we got to get the denominators to be the same. So what do we know about 9 and 3? Well, I know that if I multiply 3 times 3, I can get 9. So what we do to the bottom, we have to do to the top. If I'm multiplying 3 to the denominator, I got to multiply 3 to the numerator, and this will give us 3 over 9. So I've got 3 over 9 plus 3 over 9. That gives me 6 over 9. And what do 6 and 9 have in common? They are both multiples of 3. So then we can then take out, we can divide by a 3 and divide by a 3. And that gives us 2/3. Because 6 divided by 3 is 2. And 9 divided by 3 is 3. So we're left with 2/3. All right, so that one. Right now, what you'll notice is that all of these have an instance where both denominators are one denominator is a multiple of, or has a multiple in common, which makes it really easy. We're going to get to a couple of examples where you have to do a little more multiplication to be able to divide it. All right. But we'll do a couple more examples of this, and then we'll get to that. So I have 2 over 5 plus 1 over 10. So like we did earlier, you can multiply 5 by 2 to get 10. So let's multiply the top and bottom of this by 2, which will give us 4 over 10. Because 2 times 2 is 4, and 5 times 2 is 10. So now I have 4 over 10 plus 1 over 10. You add the numerators, and you will get 5 over 10. Now, remember when we had 4 over 8, and we said the pizza is 8 slices big, 4 of those are filled. That is half of the pizza is filled. Well, 5 is half of 10. So I can then divide this by 5, divide the bottom by 5. 5 divided by 5 is 1. And 10 divided by 5 is 2. So your answer is 1/2. All right, next we'll do one more where it's nice and we got a good clean number in the denominator. Let's do this one. So I have 5/12 minus 1/6. All right, so now notice that we have 12 and 6. Well, what can we say about 12 and 6? So if I multiply 6 by 2, I can get 12. So let's do that. I will multiply the denominator by 2. I can multiply the numerator by 2. And that will get me 2/12. So now the question reads, I have 5/12 minus 2/12. And that gives me 3/12. Well, what do we know about 3 and 12? So 3 times 3 is 6, or 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So I can remove a 3 or divide it from the top and divide it from the bottom. So if I divide the top by 3, 3 divided by 3 is 1. If I divide the denominator by 3, 12 divided by 3 is 4. So your answer is 1/4. All right, we're going to do a couple more difficult ones. If you have questions, please ask me. Because now I'm going to show you the mathematics of it, and then I'm going to show you a little trick. Now, sometimes the trick makes it a little more, there might be an easier way, or like when you understand the concepts, you can get away from the trick, but the trick works every time. There just might be a smaller common number, a least common multiple, if you will. Sometimes that is the case, and you can get there and find that, but the trick works every time. It just, you'll reduce to the same answer, get you the same number. Mathematics is very nice about can be multiple avenues to get you to the same answer. Okay, so now let's do a couple more difficult ones. So I have 4/3. I don't really like this one. Yeah, that's fine. I didn't realize it was an improper fraction, but that's okay. We already have dealt with improper fractions before. Okay, so I've got 4/3 and 2/5. Make sure you can see that. Okay, so 4/3 and 2/5. You'll notice that 3 and 5 do not have a common factor. Like, 3 does not have or 5 is not a multiple of 3. And we can't reduce it to anything smaller. They're both prime numbers. Prime numbers meaning that their only factors are 1 in itself. So there's nothing we can do by just multiplying one thing to change this. We have to do something else, which means we have to look at their multiples. And so there's an easier way to do this, which is what the trick comes in, but I'm going to show you the long way, is we got to look at the LCM, which is the least common multiple. So if I'm looking at the LCM of 5, you have 5, 10, 15, 20, and so on and so forth. So what this is this is just 5 times 1, 5 times 2, 5 times 3, and 5 times 4. So these are the multiples of 5. So now I need to know what the multiples of 3 are. So the multiples of 3 are 3, 6, 9, 12, and then 15. So right off the bat, when we're looking for the least common multiples, we're looking for what's the smallest number that these two sets of numbers have in common. So if this is a set of numbers, and this is also a set of numbers, what is the smallest number that these have in common? So let me get rid of these multiplications here, because that was just to demonstrate the operation, what we're really doing. So I've got these two sets of numbers, and we're looking for the smallest one that they have in common. Well, you'll notice that 15 shows up twice. So 15 is our least common multiple between the multiples of 3 and the multiples of 5. So what we need to do is multiply, we need our denominator to be 15. So our end result is that we will turn this into something from 15 plus something over 15. So that's what we're going to do. We're going to go from 3 to 15, and we're going to go from 5 to 15. So the question remains, how did 3 get to 15? Well, you have to multiply. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. So if I multiplied the denominator by 5, I also have to multiply the numerator by 5. So 4 times 5 is 20. So this first number is going to be 20 over 5. So we've got the first fraction done. We went from 4/3, multiplied the top and bottom by 5, and got 4 over 15. Now we have to do that for the second one. We need to know, how did 5 get to 15? Well, 5 times 3 is 15. So I can multiply the bottom by 3 and the top by 3. So if 5 times 3 is 15, 2 times 3 is 6. So this is the new problem. Is 20 over 15 plus 6 over 15. And that will get you 26 over 15. And I do believe that is non-reducible. Yes, that is non-reducible. So we'll work on more problems to know when and when you can't reduce something, but just know for the sake of this example, that is non-reducible. Okay. Let's do some more like that. Okay. So we knocked out that one. There's some harder ones in here that have bigger numbers. I'm going to try to stick with some smaller ones. So let's do this one first. So we've got 1 over 3 minus 1 over 7. Okay, so we'll do the LCM again until I'll show you the trick. So LCM, we're going to look at the factors, or the multiples of 3 first. So remember, the multiples of 3 are 3, 6, 9, 12, 15, 18, and we got one more, is 21. So we need a couple multiples of this one. So then the multiples of 7, so here's the multiples of 7. Here's one set of numbers. Here's another set of numbers. The multiples of 7 are 7, 14, and 21. We could keep going, but there's really not a huge point to that, because we have our answer. So you notice that 21 is a multiple of 3, and 21 is also a multiple of 7. So I'm just going to go ahead and do the same thing we did earlier. I'm going to rewrite the problem in the numerator to say that this is something over 21 minus something over 21. So how did 3 become 21? Well, if 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 was 21. So if you multiply 3 by 7, you get 21. So we have to multiply the bottom by 7, and we have to multiply the top by 7. So 1 times 7 is 7. So this first fraction will read 7 over 21. The second fraction, 7 to get to 21, was multiplied by 3, because 7 times 1 is 7, 7 times 2 is 14, and 7 times 3 is 21. So if I multiplied this 7 by 3, I also had to multiply the top by 3, and that gives us 3 over 21. So our new problem is 7 over 21 minus 3 over 21. So what is 7 minus 3? Well, that's 4. So our answer to this problem is 4 over 21. That is the answer. That is also non-reducible. 21 cannot be divided by 2 or 4. Those are the only options to reduce this any further. So 4 over 21 is the full answer. We'll do one more with LCM, and then I want to show you my little trick for solving these a little faster. Okay, so let's do a little bit of a more difficult one. This one up here is pretty good. So we did this one. So we have 5 over 9 plus 2 over 7. So using LCM, we have to find a number where 9 and 7 have what is their least common multiple. So we're going to do our LCM. We're going to look at the multiples of 7, which are 7, 14, 21, 28, 35, 42, 49, 56, and 63. So we needed quite a few this time. So 7 times 1 is 7, 7 times 2 is 14, times 3 is 21, times 4 is 28, times 5 is 35, times 6 is 42, times 7 is 49, times 8 is 56, and times 9 is 63. So then our multiples of 9, we've got a second set of numbers here. We have 9, 18, 27, 36, 45, 54, and 63. So 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 64, and 9 times 7 is 63. So our new one, our denominator is going to be 63, and this denominator is also going to be 63. So how did we're going to add these together. How did 9 get changed to be 63? What operation or what multiple had to occur for 9 to become 63? Well, 9 times 7 is 63. So if I multiplied the bottom by 7, I also have to multiply the top by 7. So I have 5 times 7. Well, 5 times 7 is 35. So our first new fraction is 35 over 63. Well, 7 has to become 63 as well. So how did 7 become 63? Well, it was multiplied by 9. So if I multiply the denominator by 9, I also have to multiply the numerator by 9, and 2 times 9 is 18. So our new problem is 35 over 63 plus 18 over 63. So we've got 35 over 63 plus 18 over 63. So we'll add those together. 35 plus 18 is 53. 53. And so we have 53 over 63, and that is non-reducible. So that is our answer, is 53 over 63. Now, like I said, that one, they can get a little longer, but there's a much faster way. If you have a calculator, you can do most of this. It just kind of helps to know how to do it. This trick, definitely with a calculator, you can knock these out pretty quickly without having to do too much handwork. So the easiest way to approach one of these problems is, I'm just going to use x and y for example. So I've got x over y plus Nah, it's not a good way to do it, because it's gonna, if we use different ones, it's good for certain audiences that are used to using variables, but if you're not accustomed to using variables, you're gonna have, zx over yz, and you'll have, so if that was xy, we would need something else. If we were doing r, well, anyway, we're not gonna worry about that. We'll use 1 over 2, and we will use 1 over 3. So we'll use a real example, just a real simple example. So how this trick works is that I'm just going to immediately multiply this way, multiply this way, and multiply this way. So these are all operations of multiplication. So we're going to multiply this direction, and through the bottom. So basically we're going this way, we're going diagonally, and we're going diagonally in the other direction. So if we're going across this way, 2 times 3 is 6. So that's going to be our denominator. Then you've got 3 times 1 plus 2 times 1. So we'll think about that. So you multiply straight across, you got 6. You multiply this way, you got 3 times 1. Multiply this way, you got 2 times 1. So what is 3 times 1? That is 3. So I have 3 plus 2 times 1 is 2. All over 6, that is 5 over 3. Or 5 over 6, sorry. 5 over 6. Done. You don't have to do LCM. You don't have to look for the least common multiple. You just multiply straight through the denominator, multiply diagonally this way, multiply diagonally this way. So let's practice that for a couple of these harder examples. And just to show you, when we were doing that 7 and 9, we had to go through a lot of numbers. There's just kind of a lot of things going on. With this trick, you can just kind of bypass that and not really worry about it. So we have 7 over 8 plus 4 over 5. So we're going to use the same trick. I'm going to multiply this way, I'm going to multiply this way, and I'm going to multiply this way. So first things first, we have something over 8 times 5 is 40. That's going to be our denominator. 7 times 5, so I've got 7 times 5 plus 8 times 4. So 7 times 5, that is 35. 8 times 4 is 32. And that is all over a denominator of 40. So 35 plus 32 is 67 over 40. And that is your answer. So this really, really speeds things up. I'm writing the whole thing over 40 so that you don't have to do, this over this is 40, plus over this is 40, because the denominator you've already decided is going to be 40. Let's do a couple more. And again, if you have questions, I would definitely practice both methods on your own. And you can always ask me for questions. Okay, so let's do 6 over 7 plus 2 over 6. So we're going to multiply this way, and this way. So 7 times 6 is 42. So 42 will be our denominator. 6, and we've got 6 times 6 plus 7 times 2. Well, 6 times 6 is 36, so I've got 36. 7 times 2 is 14, and that is all over a denominator of 42. So 36 plus 14 is 50. So I have 50 over 42. Now this is reducible once. Notice that, so we've got 50, which is divisible by 2, and so 1, 2, 5, 25, and 50. 42 is also divisible by 2. So I can take out a 2 from both of these. So let's go ahead and do that. So 50 divided by 2 And 42 divided by 2 gives me 25, because 50 divided by 2 is 25. And 42 divided by 2 is 21. So our answer is 25 over 21. And that's just that these two things are equal. This is just, taking out a common factor. So you have LCM, and then you have GCF, which is greatest common factor. So we took out the GCF. If we need to do a video on GCF, I can also do that, because that's an effective way of understanding why you reduce, or how, and the best way to do that. So I can also help you with that. But just remember, least common multiples and greatest common factors. All right, let's see. We've gone for 30 minutes. Let's do one more. All right, let's do a big one. So let's do 2 over 8 plus 3 over 9. So same thing, we're going to go this way, we're going to go this way, and we're going to go this way. So 8 times 9 is 72. And then we've got 9 times 2 plus 8 times 3. And I'll put it in parentheses. I wasn't doing that earlier, but PEMDAS is a useful thing. I mean, technically with PEMDAS, it would do the same thing anyway. You would multiply the two numbers before you add them, so it's already okay. But parentheses just adds another layer to that, and it looks neater for some people. Okay, so we got 9 times 2 is 18, plus 8 times 3 is 24, and that is all over 72. So 18 plus 24 is 42, and that is over 72. So we can reduce that, because 42 can be divided by 2, and 72 can also be divided by 2. So let's do that. Let's do 42 divided by 2 over 72 divided by 2. And that'll give us 21 over, what is that, 36? 36. That can actually be reduced further. You can take that one step further. So 21 can be divided by 3, and so can 36. So we got to do this one step further. This is where greatest common factor would have played into knowing 6 goes into both of these. 36 divided by 3. So 21 divided by 3 is 7. And 36 divided by 3 is 13. No, 12. 7 over 12. So your answer is 7 over 12. Where greatest common factor would play into this is you would know that 6, and I don't know why I didn't realize this earlier. I could have seen that for myself. 6 goes into 42 and 72. So you can divide both of them by 6. If you divide by 2 into both of those, you'll get to 21/36, and then you'll realize, like I did, that, oh, these have a common factor as well, which is 3. And so taking out a 3 and a 2 is the same thing as taking out a 6. That might be confusing. Please ask questions, and I can absolutely help with some of that understanding. But let me know if you have any questions, and I'm here to help.